has 7 types: bang, int, float, symbol, list, signal, and matrix. And we will look in depth at an awesome table I made that shows lots of ways of converting among these types. This lesson, we're going to talk about all the ways of getting from one type to another. So you're going to get a lot of shallow knowledge about specific objects with specific behavior that you may want to use in the future, but I'm hoping that you're also going to get a lot of deep knowledge about what does it mean conceptually to go from a bang to an int, for example. So I made this table that I'm quite proud of. It's got all these 7 types of max: bang, int, float, symbol, list, signal, and matrix. And those are the labels of the columns and the labels of the rows. And the idea is that the row says what type you're coming from, and the column says what type you're going to. So it's a 7 by 7 matrix, so there's 49 squares. So I'm gonna talk through all these 49 possibilities, and we're gonna take them in order like we read English text, left to right, top to bottom. So we're gonna take it row by row. In other words, first I'm gonna tell you if you have a bang, how do you turn it into another bang? How do you turn the bang into an int? How do you turn the bang into a float? How do you turn the bang into a symbol, etc. And then after we're done with that, we're gonna say suppose you have an int, how do you convert it into all these types, and so on. The full high resolution version of this table is available as a downloadable resource so that you can refer to it in the future. I realize that there's a lot of text on this table and that in the video it's gonna be too small to read. So that's why there's these cool effects that are showing you as I talk through it how we're going through the table. Okay, so let's dive into this first row of the table, answering the question, how do we convert from a bang to every other type in max? And that's why I've got this max patch called from bang to anything, and you can see that there's sort of multiple columns of this max patch, and those are supposed to correspond to the multiple rows of the matrix. So over here on the left, we have getting from a bang to a bang, which of course the button can do. So if a bang comes into this button, what's going to come out is another bang, and it's red to show you that we're trying to draw your eye to the button in the middle. Although in this particular case, all 3 of these buttons are pretty much identical to each other except for this one being red. So that's not telling you too much. But here's another object that we've already seen called delay, and if a bang comes into this object, then 1 second later another bang comes out of it. With delay, it waits however much you asked for from the last one it received. So I'm clicking it less than 1 second apart, and nothing's coming out yet. And finally, when I stop, after 1 second after the last one is when delay outputs. Also, the object trigger can receive any type and it can output any type. And importantly, it has an argument L, which originally stood for list, but now I think of it standing for leave it alone, because no matter what type you put in, if you say TL, if there's an argument to trigger that is L, then the corresponding outlet will not change the type of what goes in. So if an int comes in, an int comes out. If a float comes in, a float comes out. That's the behavior of L. If you say B, then you're saying no matter what comes in, I want a bang to come out. Or if you say I, it means you want to come out as an integer, and trigger has all these rules for converting types. You know, what integer should it use if you send a bang? Let's find out. I don't know what integer it uses. Let's ask. So if this said TI and we put a bang into it, what integer would we get? I'm guessing it's 0, because what would be another default integer? And indeed, it's a 0 that comes out. So if the type that you asked trigger to give you is different from the type that goes in, then it does some kind of conversion. But L, again, the leave it alone argument just doesn't do any conversion. It just passes whatever type is received. Okay, so that's how to get from bang to bang. How about from bang to int? Well, we've seen the counter object, 0, 1, 2, 3, 4. So every time it receives a bang, it's just counting up, going up by the next integer. We've seen the random object, where the argument tells it the range of integers that it's allowed to output. So here it's going to give me a number between 0 and 9 every time I bang. And so each of these bangs is making a different integer come out. There's also an object called table. We haven't looked at this yet. Table, if you double click on it, it brings up this graphical editing object. And the idea is that you can associate one y value with each x value. And by default, it's 127 by 127 table. So it's good for making some kind of a curve that maps MIDI data from MIDI data to MIDI data. But you can of course change that in the inspector by sending a message to get a different size table. So normally you send an integer to the table and just looks that up as the y value. The integer that receives is interpreted as an x value, and it looks at the y value corresponding to that x. And it outputs it, as we'll see in a moment when we talk about getting from ints to ints. But if you're getting from bangs to ints, you can send a bang to the table, and it will be treated as a probability distribution. So right now I have all zeros, so it means that what does it mean? Probably means that it doesn't know what to output. It just outputs 0 every time. But if I say that the x value of 50 has a value of 82, that means that it has a probability and nothing else has a probability. So now every time I click it, I'm going to get a 50 because 50 is the only non-zero value in the table. And if I put another non-zero value with a little bit lower value, 85, maybe half the height, then approximately 2/3 of the time it's going to output 50, and 1/3 of the time it's going to output 85. And indeed, that's what it's doing. So it's mostly outputting 50, but sometimes outputting 85. And we can say that all of the high numbers are possible, but with a low probability. So basically, I'm drawing what a statistician would call a probability density function. And I'm saying this possibility is highly likely, this one is medium likely, all these possibilities are very unlikely, and every other possibility is completely impossible. And every time you send it a bang, it picks a number from that distribution. So you can see still most of the time it's 85, and a lot of the rest of the time it's 50, and then every so often you get one of these high numbers like 118 or 124, etc. So that's using a table as a probability distribution, and you just send it a bang, and an integer comes out. Now the most common way of using a bang to get an int or a float or a symbol or a list is to resend the current value. So I have a whole sort of category, a whole zone in the bottom part of this patch that shows that. So for example, if a message box has an integer in it, and you send it a bang, it re-outputs that integer. If a number box has an integer in it, and you send it a bang, it re-outputs that same integer. If you're doing arithmetic, if you're adding together two numbers, 58 plus 19 equals 77, if I send another bang to that plus, then it re-performs the arithmetic and makes the 77 come out. And we saw that's a way to get around the cold inlets. So if I want to know 58 plus 50, well, I can tell in my head it's 108, but I put a 50 in the cold inlet, so nothing came out. But now if I bang, then it'll perform the calculation, and the 108 will come out. There's also an object specifically just to hold an integer. It's called int, int down here, and it has a hot inlet and a cold inlet. And if it has an integer in its cold inlet, then it's storing it in its memory, and when you send it a bang, then that integer comes out. Likewise, everything I just said is equally true for floats. So here's a message box that has a float in it. Here's a floating point number box, which if I bang it, it re-outputs its current value. Here's floating point addition, so 1.07 plus 1 plus 0.11. If I click on bang, it performs the arithmetic. There's an object called float, just like int, that can store a float. How about 3.14159? That's a pretty useful floating point number. Otherwise known as 3.142, because this is a not very wide number box, so we can make it wider and we get the full 32-bit float. And there you go. Send a bang, it comes out of the float. What else can you do with a float? I couldn't think of any other way to get from a bang to a float. The notion of counting is sort of intrinsically an integer kind of concept. I don't see I mean, obviously you can rescale the output of the counter to a floating point number. You can rescale the output of random to a floating point number. You can rescale the output of table to a floating point number. I couldn't think of any way to get directly from a bang to a float except for these resend current value kinds of examples. Likewise, a symbol. First of all, bang is the symbol BANG. So if you look at the max window, if you click on this button, then what gets printed in the max window is bang, and that's exactly the same as if I click on this message box that has BANG spelled out. There's absolutely no difference. They're sending the exact same message, the 4-letter symbol BANG. That's what a bang is. So in a sense, it doesn't, it's not really meaningful to say how you convert from bang to symbol because bang is already a symbol. But bang is this very specific symbol that has a specific meaning to a lot of max objects. And in particular, there are a bunch of ways. Let me close the max window. There are a bunch of ways of resending the current value with that is a symbol with bang. So you can have a message box that holds a symbol, and when you click it, or if you send a bang to it, then it will output its value. There's also an object called zl.reg. It's like a register, exactly like the integer and float registers that you just saw over here. That holds typically a list. As this example shows, it can also hold a single symbol. So this one's argument was one symbol, so that's what's in it by default, and we can send another symbol into it and click it, and the other one comes out. So this is storage for exactly one. Well, it could be a list or a symbol, but in this case, what we're storing are just single symbols, and so the bang can recall those symbols. How about getting from a bang to a list? Well, one thing you can do is you can use the collection object, and you can put several lists in your collection. Here you can see my 5 lists that I typed into the collection, and if you send a bang to a collection, it means output the next value. So the first time it receives a bang, it outputs its first value. The next time it receives a bang, it outputs its second value, and so on. So you can iterate through a collection by sending it a bang, and by default, after it gets to the last one, you send another bang, it loops back to the beginning. So first, second, third, fourth, fifth, first, second, third, fourth, fifth. So it's just gonna keep looping infinitely if you just keep sending it a bang. So you can have a collection full of integers or floats or symbols, and then each bang would output the next value of that collection. Here I'm just showing the examples of lists. Also, there are ways of resending the current list. So the message box you can use like a zlreg. You can send something in the right, and it'll remember it, and it'll actually display it for you on the screen. And when you send a bang in the left, it'll output. So this one is again using print. Let me zoom out a little bit. So here's the max window, because zoom out a little more to see it. There's 2 bangs before. So if I bang this, it says you can also use a message box like a zlreg. So if I put a list to store into the right inlet of both of these, zlreg and this, then you see that it changed to be a list to store. And now if I send a bang to both of them, then it's going to come out of the message box and out of the zlreg exactly the same. And if we store another list in both of them, then now it's ready. It's stored in the memory. And if I send a bang, then we see another list 1, 2, 3 coming out of both of these objects. So zlreg, short for register, is a way of storing a list in program memory, and you can also store it just directly in the message box. Okay, so that's getting to lists. How about to signals? So I thought of 2 ways that it's meaningful to get from a bang to a signal, and signal processing has to be on for this to happen. So there's an object called click tilde that outputs all zeros, except when it receives a bang, it outputs a single impulse, one sample whose value is 1 in the midst of a stream of zeros. So there's a lot of silence coming out of this object, but every time it receives a bang, it outputs a single sample whose value is 1 amidst this stream of 0 samples. Another object that outputs a signal in response to a bang is count tilde, and count tilde is just like counter, except that counter is counting the number of bangs that it receives. Count tilde is counting the number of samples that have elapsed since it received a bang. So when I send it a bang, it's going to start counting up at 1 integer per sample. So you see now a few seconds have gone by since I clicked on this, and we're already up to 500,000 values. So this oscilloscope is going, I think, from 0 to 10 million or something, and we're soon to get to the end of the ability of the scope to display this number, and now it's off the screen. And if I click it again, it goes back to 0. So every time count tilde receives a bang, it resets its count to 0, and then it's just counting up at one value per sample. So it's counting the number of samples that have elapsed. So typically you need to scale this way down to do something useful with it, because these are some very big numbers. Okay, how about getting from a bang to a matrix? Well, we saw the jit.noise object, which will make a matrix full of random values. So here I'm saying I want 4 planes of character values in a 320 by 240 matrix. So every time I click this button, it's going to roll the dice 320 times 240 times 4 times and make up 4 random values for every one of these pixels. And it's basically giving me a whole bunch of random pixel values, otherwise known as static. It does that every time you send it a bang. There's also an object called jit.movie that is a way of playing a movie. So I read in the basketball movie from the Max, it ships with Max. It's one of the movies that's built in. And typically you connect it to a QMetro so that every time you need the next frame of video, a bang goes into it. But you can send it bangs directly, and it just outputs its current frame. So it's going along, it has a certain time, it's trying to play the movie at regular speed, and it's looping the movie. And if I click it fast enough, then I get a decent frame rate on the movie here. And if I click it slowly, then I get a very slow frame rate. But the idea is that every time it receives a bang, it outputs the next frame of the movie. Not the next frame of the movie, but the current frame of the movie. So if 15 seconds have gone by since the last frame, since the last time I received a bang, then it'll give you the frame that's 15 seconds in the future. It always gives you the current frame. So it's got a clock inside. It knows where it's supposed to be in the movie, but it doesn't output the frame unless it receives a bang asking it to do so. Finally, last thing I want to show is an object called jit.desktop that can do screen captures. So I'm asking for a 320 by 240 section of the screen, and it's going to be the upper left-hand corner of the screen. And because I'm starting at 0, 0. And so when I click that, it grabs those 320 by 240 pixels from my patch. So here I'll put this Finder window over in that corner, and I'll bang it again, and I'll do it again with that a little bit out of the way. So this is how you can capture the pixels that your operating system is currently displaying and get them into Max as a jitter matrix that you can further do whatever you like with. And you send it a bang when you want to let that happen. And you can set where it takes it from. So now I can move over. I can start at x equals 144, and if I select that, you see that it's from further over in my patch, and I can increase y, and I can obviously set where you're taking it from and the height and width of the rectangle. That's all the ways I can think of turning a bang into a different type. Okay, the next row of my table tells us how to get from an int or integer to all of Max's types. To get from an int to a bang, well, you can go through a button. And also the Uzi object is a way of getting from an int to that many bangs. It looks the same, but as you know, there's 5 bangs that come out of Uzi when you send it to int 5. Okay, that's from int to bang. From int to int, the pipe object will delay int. So as I scroll up to 43, the output scrolls up to 43 a second later. The table object that we just saw, you can use not only as a probability distribution, but as a lookup table. So I can draw some function in here, and then I can read values from that function by sending integers into the table. So it converts the integer that is the index, the x coordinate of the table, into the value, the y coordinate of the table. Of course, all the arithmetic you can do on integers turns integers into integers, such as multiplying by 2. And again, L for leave it alone as an argument to trigger. TL leaves alone an int, and it makes an int still be an int when it comes out of trigger. Okay, next cell, how do you convert from an int to a float? Well, if you have an arithmetic object that works with floats, then if you send in an int, it internally converts it to a float. So I can send in these integers, and the integer gets converted to 8, the floating point number, and then a floating point addition gives me 9.5. There's also the object scale, which you can say, like, let's say you've got a MIDI fader that goes from 0 to 127, and you want to remap it to the range -1 to 1 as a floating point. CL is very good at that kind of thing. That's what it's for. Okay, how do you get from an int into a symbol? Well, there's an object called toSymbol that will turn things into symbols. So notice how this message box has double quotes around it. This isn't the number 18. You know this because if we try to add 1 to it, it's not going to work because 18, the number, you can add 1 to, but 18, the symbol, doesn't mean anything for arithmetic. So this is not, the number 18, this is the symbol of the numeral 18, the ASCII character 1 followed by the ASCII character for 8. If you send an integer into trigger and you ask it to convert it to a symbol, you get a very unuseful thing, which is the null symbol. You get a symbol of length 0, a symbol that has 0 characters inside it. And so when you send integers into TS, it prints absolutely nothing. So this is not a meaningful way to convert an integer into a symbol that depends on what the integer is. This is a way to convert an integer into a length 0 symbol, the null symbol, as this says. And also the sprintf object can convert, you can make a symbol out of a number, such as by sticking the word foo onto the front of it. Finally, if you have a collection whose keys are